This next section will look at the light animation subsystem. I'll follow the same pattern as before, which means that I'll start off by looking at how the animation JSON and flat buffer files are ingested. That part has been boring, and it's the later parts that are more interesting with some hidden gems, so I'll keep this one short. We'll try to find out how the animation is performed. There are also disabled portions of code that are used to glitch the backpack lights. These may be interesting for someone to enable in the future. Then we'll dig into some of the IPC messages. These may give hints at how the cube lights work. In the future, it might be interesting to look into how the graph evaluator is used to animate or otherwise control variables that are used to animate not just the lights, but animate the motions and mood and dynamic aspects of Vector's mind. I like to sketch out a mental model of how I think the pieces might go together. The structure helps me place the pieces of code as we go through them into a bigger picture. It won't be right the first time, so I'll try to update it by the end. The basic idea, I think, is that the animator loads an animation file on demand and can play that. Or if there is no animation file, it may play the lights based upon the status of the system, creating an animation programmatically. From there, it can glitch the lights. That code looks like it's disabled, but it's kind of interesting to dig into that. And then for the backpack lights, it would probably send messages to the Vic robot, which would then pass them on to the body board, and which would then control the lights on the backpack of Vector. For cube lights, it might pass them through one of the IPCs, either to Vic robot or directly to the Vic Bluetooth daemon and Bluetooth stack, which then sends small Bluetooth LE commands to the cube, which is set up the cube light animation patterns. We should start here with the flat buffer definition for the animation. It has a series of tracks in it for the different aspects that can be animated. Each of these tracks has keyframes, and a keyframe can start at a trigger time. It's given in a milliseconds offset. And then in this case, it has, for backpack lights, it has a duration for the frame, and then colors for each of the three lights. The colors are RGBA, given as an array of floats. This structure is essentially the same as what's in the JSON file for backpack lights, and kind of similar to what appears to have been used for the cube lights. For now, we'll kind of not look into the cube light definition. We might look into that in the future. I don't find the animation loader to be particularly clear-cut, but here are some highlights. The animBackpackLightAnimation.h file, it provides an interface that's going to be able to use the JSON. The JSON loader comes in and it receives different keys than the flat buffer system does. I don't know if this is still was intended to be a legacy thing that they're going to transition or not, but the fields are interesting here and kind of give us a clue as to some of the intention and differences from the keyframe model. So it has a series of on colors given as an array. So that's probably the RGB values for each of the lights during what it's considering to be an on period. Then there's an off colors, so that's probably the same RGB values for each of the lights for when it should be in the next phase, an off phase. Then it has a period of time that it's going to be in the on phase. Down here it has a transition on period, which I'm not sure, but probably guess here is that it's going to be the amount of time after it completes the on period, the amount of time it's going to linearly transition from this on color to the off color. And probably just do a linear transition over that. Then there's a period of time that's going to stay in the off color, display that, and that's in milliseconds. Then there's going to be a transition from there to the next color, probably another linear transition. So these are probably given as that. And with the keyframes, it essentially just treats a keyframe as the on period and with some information about the transition time. Then here they have the offset, which I've been believing to be the time offset for each of the lights. That way, each of the lights in the JSON file, they wouldn't all be necessarily in sync. It would let them one be offset by, say, a second or two, so the colors would be cycling there. But ultimately, the best way to find this out is to play with the lights and then see what the patterns appear to be. The animBackpackLight's component file is the module which is used to select the animation, whether that's from a file or internally generated, to display in the backpackLights. It seems to use a priority system here based upon the internal state and then what might be triggered by the behavior tree in the engine. So it says here that its critical backpackLights take precedence over the lights set by the external engine. So usually, from what I can tell, the engine has the behavior tree, and that sends triggers as to which backpackLight should be used, which animations should be used, and that gets selected. Here it says that some internal status can take over and change those lights. So it says low battery, offline, streaming, charging, and then finally the selected one from the behavior tree. I think in below we'll see that there might be some other ones that are used as well, that maybe this comment is a little bit out of date. So we see here that there's some methods here to set which backpack animation to use or what trigger name to use. They also have a pairing light. That wasn't mentioned above earlier there, but the pairing light appears to have some priority. It says highest, but who knows if that truly is in practice. There's one for the mute light as opposed to the audio streaming. Then there's something here for Alexa notification. This looks like they're just capturing some state of the system to help debalance it, and so that this does not have to have a lot of interaction with the intricacies of the rest of the system. Again, self-test running, so they probably use this as they're testing the backpack lights out during, say, a manufacturing or developer test to see what they are. And they have a battery status here that they're gathering that to tell perhaps how much they should reflect the battery level on the backpack lights. Method here to start playing the lights, probably from given the source of all these different possibilities, something above this method probably selects the source based upon those priorities and then does it. And then this one looks like it says it sends actual backpack light message to the robot. So probably the VIC robot process. So it's probably it's packing up the various IPC messages to send to that, to how to actually draw the lights based upon whether or not it was the data file, animation file, or internally generated. And then some methods here to it looks like just further update the state of things. And then down below, I'm not real certain what all of these are. This backpack trigger to map name appears to be, so all the backpack trigger animation, as well as almost all of the animations and behavior trees are hard-coded into the system at the present time. Ideally in the future that would be removed. Looks like here there's some extra help for these. And then which of the system state lights that it's using. And then some information about the status of the system. It probably gets this information so it doesn't settles on this and then use this in its decision logic to decide which one to use, as opposed to querying many modules, possibly remote modules that are in a different process altogether. So let's look here in the C++ file. So we have the file at the top, all the usual header stuff. They have a couple console variables. Not real clear what this is. Offline time before lights, offline check frequency. This might be something to do with its inability to connect to Wi-Fi or the internet or servers. Let's continue down. So update critical backpack config. Looks like this is used to decide what's going on and if that should drive any of the backpack information for critical things. So we use charging contacts as a proxy for the only case where we need to show the low battery light. Interesting, it looks like they were considered some cases here. Charging, disconnected, interesting. They also have some support here for self-test. So it looks like they didn't use a separate application here at all for self-test. Although they could have, they interwove it within the main application. Looks like they have some timers here just to drive whether or not they should switch away from some of the offline backpack animations, I guess. And then finally, handle the animations related to a behavior. Oh, and yeah, here's a link here for Alexa notifications. Apparently they can set their own backpack light. I did not know that. More charging stuff, some debug information. Then here looks like this would be called regularly in, I don't know if this one's driving the animation or just selecting it. It looks like as it goes through, it at least is sending backpack light configurations to the robot process. And down here, so let's see here. Behavior lights are triggered from the engine are used to show the state for an active behavior. We want these specific behavior lights to take precedence over some of the critical lights. So sometimes the critical lights are not the highest priority, sometimes the engine ones are higher priority. But the way the system was set up, all critical lights take precedence over that. This is a little workaround so that we can determine if a higher priority behavior light, which is triggered from the engine, should take precedence over the current critical light. So there's probably a complicated decision process that, if we're under to try describing how this happens. So they have some spinners working on it, and dance to the beat and meet vector all are the only ones here that are used to set true. Everything else sets false. Some methods here to set the backpack light animation and to kick it off, start running. And these look like the maintenance. I don't fully know what's happening here. It looks like they're moving through a list, but I don't recognize what the code might be doing. Here, okay, so send packet to robot, engine to robot. So yeah, looks like they're sending the backpack, individual backpack light frame. They compute it out at some time interval, perhaps every 30 milliseconds, or whatever it would be for 24, 25 frames a second. Compute out what the lights should be transitioned to, and then send that information off to Vic Robot through an IPC mechanism. Here, the set backpack lights with the trigger, that's used to look up the, maps that trigger enumeration code to the map name, looks up some sort of animation for it, and then tries running that. Here's something looks like they're trying to use with the prioritization. Not immediately clear how this works. And again, here they're trying to go through and identify which thing to use based upon the priority and such. Checking to see if they should have the pairing light on or off. And then some logic again here to decide if they're streaming or not to what kind of light pattern is. And then it looks like down here they're computing certain kinds of custom animations for the different lights. So if its lights are off, these are the kind of colors and patterns it would use. If the lights are, it's in a pairing state, it looks like it would pulse yellow. I don't recall seeing that. If it's streaming, it's pulsing cyan, it says. And that looks like that would normally kind of crawl or walk in my recollection. There's a self-test here, which is perhaps all white. And then it gets down to here is if user space is unsecure, then a mix white in with the system light as the off color, normally green. Do not know what they're trying to do there. Don't know what that's trying to say. And then it looks like, yep, they're sending that off to the robot. So it's probably not, none of these transitions are non-zero. So it looks like they're just pretty solid light patterns that they're using there. And they're just sending it straight off to the robot so they don't have to compute it in intermediate frames. Some more helpers to check what state it is and probably decide whether or not they can get away from showing certain backpack lights and drop to lower priority ones. And then something here to just grab the, yeah, this looks like this is a message from Vic Robot, which says what the status of the battery charge is. So it's getting those values and caching here. That's probably its only way of knowing what the battery and charging is for displaying the low battery, because it's a separate process altogether. Easter eggs in the code is in this backpack layer manager. It doesn't do anything other than add in a glitching. What it looks like, judging from the signature of the call, is that from time to time they call generate glitch lights. Maybe that's part of a behavior, perhaps it was something else or randomly chosen. And it takes an animation track for the backpack lights and modifies that, perhaps changes it, perhaps inserts some other stuff to do glitching. The comment here says that they actually had a to-do item to restore the glitching. So maybe they did this in Cosmo at some point, or were exploring this as a research item, but ultimately decided to turn it off and to bring it back some point in later. The date on this is 2017, so this was quite some time early in the beginning of the project, so they had quite a while before the end of development at Anki to bring that back. So let's dig into the code for the manager here. There's a couple console variables. The first one is a delay of how long before they start glitching the lights. And then the other one is how long each light keyframe is for. I don't really know exactly quite what to think of that yet. It could be that they just inject a bunch of keyframes in there to blink the lights and then go back to the other one. So let's take a look down here at the method. So right now all the code is commented out. It's been disabled for this method. They just clear the track. If they were to generate the lights, they just turn them off. So this is probably at the beginning or end of a track, or when it's otherwise idle and not displaying backpack lights. So let's see here. First of all, they turn off all the lights in there. So that's the first, looks like that's going to be the first keyframe. Then they turn the middle light on, and they have that duration there for the keyframe. They pick a second random light, other than the middle one. So back, front, left, right. These names seem to probably make it suggest this is probably related to Cosmo days, because I don't know that there are that many lights in that kind of structure in Vector per se. Then they pick a second random light that isn't the first one, and they basically kind of like using a card deck. They shuffled it and they picked a card from the deck, and then they're just removing this so that they ensure they don't pick it again. So then they create another keyframe. So the first one is they clear them all out. The second one is they turn on the middle one. Then the third one is they turn on the middle and this random light. Then they're going to clear the middle light. And then the final two keyframes is they pick a third light to turn on and turn that on. And then finally they turn off all the lights and go back. So that must be just probably a glitch at the beginning or end. I don't know if they would do it in the middle per se, but maybe they did. That would just be a few frames long to turn on up to, is it 4 steps, 5 steps? So off, middle something in another one, and then off again. Very clever. Might be fun someday to be able to turn that on and enable that. Finally, I want to look a little bit at the CLAD file for the Game-to-Engine IPC. These are messages which I think are sent probably from the animation engine to the robot or to the Vic engine behavior tree. Some of these messages, I get the feeling that actually aren't used, and some are. It's not real sure, but some of these things aren't even defined. These things that types that it refers to in the C-like file aren't defined anywhere, and I wonder if that CLAD thing just doesn't generate code for things it doesn't know about. It's real unclear to me. But in this case, the first one is a set active object LEDs. I don't know. I suspect these, when it says active object, this might be referring to something in its visual field, that is to say cubes. And I'll try looking back at these in the future to see if, when I look into kind of the cube lights, to see if there might be something I can discern from it. it does pass a color for the on period and a color for the off period, and then some durations for those two periods in the transition. And so, so the on period is fade from off to on. That's a transition, and then the off period is from on to off. And this kind of matches the JSON file piece that we saw, that decoder in the beginning. Maybe the JSON decoder decodes CLAD stuff. Maybe that's sent as Java or JSON files. We also have that offset into it. The time step for that light might be different than the others. It's not real sure what these relative are. It seems to be some sort of part of some sort of mode here. And it could be that maybe these lights are intended to circulate around or something. We see a similar one here. It just happens to be that they broke out the colors, so for each of the 4 lights on something. Could be a cube, or it could have been the original backpack on Cosmo. Again, it has this make mode relative thing. What we really see, though, is of interest that for right now is the backpack lights. Again, this looks a lot like the JSON scheme that we saw in the beginning. So, and this is passed effectively through something, possibly through Vic Engine, definitely at least some point to Vic Robot. Then it gets transmogrified and sent off to the bodyboard for displaying on the backpack lights. So it has 3 of these right here, and that is not the RGB colors. That's 3 for each of the LEDs. I think on the backpack lights they treat the 4th light special and separate from these that can be animated, and so that when they pass these around, they don't pass that light in this way. Each color is a packed RGBA color, ignoring the A field. So there's the on, off, on period, off period, and then the transition between these and the offset for each of the LEDs. And I don't know if it's because of CLAD or if it's because of a style where they just didn't make one of these things for an LED and then make an array of 3 of these structures, as opposed to having each structure have it separated out internally. But right now, that isn't too informative, too informational about the backpacks there. We will see a little bit more into the cube light structure and what kind of hints and that tells us about how to think about light control in a later video.